Let us look at powers of a binomial. Now, in the previous session, we learned the identities a plus b square and a plus b cube. Now, how about other powers like 0, 1, 4, 5, and so on? So, what does that mean? A plus b to the power of 0 is 1. Remember, anything to the power of 0 is 1, except if a plus b is equal to 0. Then we can't have 0 to the power of 0. So, except in that case, a plus b to the power of 0 is 1. A plus b to the power of 1 is a plus b. And we have seen a plus b square is a square plus 2ab plus b square. A plus b cube is equal to a cube plus 3a square b plus 3ab square plus b cube. So we have seen all this. Now, a plus b to the power of 4, again following what we learned in the previous session, we arrive at a to the power of 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the power of 4. Now, as we can see, it would become more and more difficult to expand the power for higher powers. So as we go to 5, 6, 7, 8, and so on. Now here, if you notice, the powers of A starts from the power of the binomial and keep decreasing by 1. So A to the power of 4, 3, 2, 1. If nothing is there, it means A to the power of 0. And the powers of B keep increasing by 1, starting from 0. So here B to the power of 0, 1, 2, 3, 4. But in every one of these terms, sum of the powers of A and B is always equal to the power of the binomial. So here we have 4, power of binomial is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4 and 4. Now, since it becomes more and more difficult for higher powers, let us see whether we can identify some pattern to find the coefficients. Focus on the coefficients of this. In the case of to the power of 0, it is 1. The expansion itself is just 1, which means we have a constant 1, which we can treat it as a coefficient if we take it as 1 times something to the power of 0. So 1 becomes the coefficient. Now, in this case, 1 is the coefficient of A, 1 is the coefficient of B. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now, let's just arrange them in a particular manner. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now here we have 1, 1, 1. So in every row, first number is 1 and the last number is 1. Or in other words, the coefficient of the first term is 1 and coefficient of the last term is 1. And now if you look at the other ones, so here we have 2, that is the sum of 1 plus 1. Here we have 3, that is 1 plus 2, 3, 2 plus 1, 3. Here we have 4, so 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and 1. So we have found a pattern. By the way, this is called pyramid of coefficients. Now, notice that 1 appears in the first and last positions. Other numbers in a row are the sum of the previous row's 2 numbers just above it. This triangle of numbers is called the Pascal's triangle. So, for A plus B to the power of 5, what would be the coefficients? So, we use the 5th row of the Pascal's triangle. 5th row means 1, 2, 3, 4, 5. Remember, we are starting from the power 0. So, for A plus B to the power of 5, we use the 5th row of the Pascal's triangle. Notice that 5th row is for the 4th power of the binomial. So what will be the coefficients of a plus b to the power of 5? Coefficients will be, we start with 1, 4 plus 1, 5, 6 plus 4, 10, 6 plus 4, 10, 4 plus 1, 5, and 1. 1 will be the starting number. 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and 1 will be the last. So the coefficients are 1, 5, 10, 10, 5, 1. Now what about A and B? Remember, the powers of A keep decreasing by 1, starting from the binomial power, and the powers of B increasing by 1. So our expression would become a plus b to the power of 5 equal to a, that is the first term, starts from the power. So 5, b to the power of 0 plus 5 coefficient, a to the power of 4, b to the power of 1 plus 10 a cube b square plus 10a square b cube plus 5 a to the power of 1 b to the power of 4 plus a to the power of 0 b to the power of 5. So using Pascal's triangle, we are identifying the coefficients, and then the first term, we start with the power of the binomial and keep reducing it in each term for the first term. For the second term, we start from 0 and we go up to the power of the binomial. Now simplifying this, since a to the power of 0 equal to 1 and b to the power of 0 is equal to 1. So if we simplify it, we get a to the power of 5 plus 5a to the power of 4b plus 10a cube b square plus 10a square b cube plus 5ab to the power of 4 plus b to the power of 5. Now, Pascal's triangle gives the coefficients in the expansion of a plus b to the power of n, where n is in the set of whole numbers. That is 0, 1, 2, 3, 4, 5, 6, and so on. If we had a minus b, then in that case, remember, coefficients will still be same. Same rule will apply in that case also. The only thing is the signs will alternate. So we'll end up with plus a to the power of 5 minus 5a to the power of 4b plus minus plus minus. That was powers of a binomial. That's it for now. Bye.